This video goes with the additional practice problems. So we want to write each one of these sentences as a conditional. So a regular hexagon has exactly 6 sides. So if a hexagon is regular, then it has 6 sides. That would be the conditional form. 2 supplementary angles form a line. If 2 angles are supplementary, just abbreviate supplementary, then they form a straight line. They form a line. That would be that one. Let's look at the next ones. Determine the truth value of each conditional. Explain your reasoning or give a counterexample. So if we can find a counterexample, it's going to be false. So if a figure has 4 congruent angles, then the figure is a square. Now a square does have 4 congruent angles. What other shapes do we have 4 congruent angles? What about a rectangle? A rectangle has opposite sides congruent and has 4 right angles. A square has all sides congruent and has 4 right angles. So the square would be a counterexample. So if a figure has 4 congruent angles, then the figure is a square. The square is true, but also what about a rectangle? It could be a rectangle and also have 4 congruent angles. That would be the counterexample. That would actually cause that to be a false statement. If the sidewalks are wet, then it has been raining. Okay. Early in the morning, like there could be fog and it could leave the sidewalks wet like dew on the grass, but still no rain. Somebody's sprinkler could be on and the sidewalks are going to be wet and there's not been any rain. So that would also possibly cause that to be a false statement, and I'm just going to put sprinklers. So sprinklers, they could be off and you come out, sidewalks are all wet, you think it's been raining, but no, it's the sprinklers have been on. It'd maybe be a counterexample for that one. Write the negation of each part of the conditional, then write the converse, the inverse, and the contrapositive, and determine the truth value. Okay, so let's see what we got. So write the negation of each part. So not a square, then not a rectangle. So there's the negation of each part. Then write the converse, the inverse, and the contrapositive. So let's write the converse of the statement. We're going to take the original statement. So if rectangle, then square. That would be the converse. Now converse form is Q then P. Q if Q then P. That's the converse. Let's write then we'll determine truth values. Let's write the inverse. Inverse, you leave the Q and the P where they're at and you put knots in front of them. So what we actually did up here was the inverse. This is the inverse right here. It's not P, not Q. So nothing's changed other than the knots are added. We call it the inverse. And then the contrapositive is you swap both of them and make them knots. So if not rectangle, then not square. That's the contrapositive. Now let's evaluate these in terms of their values, truth value. So if a figure is not a square, then it's not a rectangle. Not a square. Well, it could be, if it's not a square, it could be a rectangle. That would be a counterexample. That would make that a false statement. If it's a rectangle, then it's a square. Rectangles have opposite sides congruent, but not equal. Squares have all sides equal. That's actually a false statement. If not a rectangle, then not a square. So if it's not a rectangle, which means opposite sides paralleling, congruent, and 90-degree angles, then it's not a square. Could it be a square? It could be a square. So that makes that a true statement. Because a square has all sides congruent, which makes it not a rectangle, because a rectangle only has opposite pairs of sides congruent. So that would actually make that, if it's not a rectangle, it also makes that a false statement. Okay, so field hockey is a team sport. So if the game is not field hockey, then it's not a team sport. That would be the inverse. The converse then would be, if it's a team sport, then it's hockey. Then it's field hockey. That's converse. And then the contrapositive would be, if it's not a team sport, then it's not hockey. Then not hockey. So that's the contrapositive. So let's evaluate the truth values of these. If it's not field hockey, then it's not a team sport. Okay, so we have something not field hockey that is a team sport, like baseball. Baseball's not field hockey, but it is a team sport. So that would cause that to be a false statement, because I can think of a counterexample. Okay, if it's a team sport, then it's field hockey. Well, if it's a team sport, it could be baseball. It doesn't necessarily have to be field hockey. That's also false. If it's not a team sport, then it's not hockey. If it's not a team sport, like bicycle riding, then it's not hockey, which is true. Hockey is a team sport. If it's not a team sport, it can't. So hockey is a team sport. If it's not a team sport, then that's going to make that a true statement. Sometimes the contrapositive is hard to figure out. Sometimes what I'll do is I'll turn it back around and try to evaluate it the other way and see if it makes more sense. Let's look at number 7. Write a biconditional for following conditional. So remember, that's the one that has if and only if. And it works both ways. So two lines have the same slope if and only if they are parallel. Two lines have same slope if and only if. IFF is like if and only if abbreviation. They are parallel. So two lines have the same slope if and only if they are parallel. That's the biconditional for that one. That's going to be true. Write the distributive part of multiplication over addition as a conditional statement. Okay, distributive of multiplication over addition, an example would be 4 times 3 plus 7 is like 4 times 3 plus 4 times 7 as a conditional statement. So if if 4 is times 3 plus 7, it is the same as 4 times 11. Okay, that's kind of cheating a little bit, but it's good enough for that one. Number of people who are at least 100 years old grew 66%. Write that as a conditional statement. If you're at least 100, doesn't have to be a true statement, then your population grew about 66%. About 66%. Grew, G-R-E-W. And that's it for that one.